Hello, Mikalaba. Welcome from Clifftop Engineering again. And my name is Demita. I'm doing mechanics open lectures. And the reason I do mechanics is because it's one of the subject for those of you who are sitting international A level, further maths, and also for those of university students, science, engineering. It is very important foundation subject for you all. And in this lectures, we will use the textbook from Pearson Edexcel International. It's further mechanics 2. And we have done some of the foundation necessary for projectile motion, which is in the chapter 1. And we also already done some of the problems. And in this video, we are doing 2 problems from exercise 1A from the textbook. So now let's just look at the problem 1 straight away. So if you read problem 1, again we are doing exercise 1A, problem 1. So the problem, let's try and read the problem together. A particle is projected horizontally at 20 meters per second from a point h meters above horizontal ground. It lands on the ground 5 seconds later, and find A, the value h, B, the horizontal distance traveled between the time the particle is projected and the time it hits the ground. So if you look at this problem, the particle is projected horizontally. So this means the initial velocity in the y direction will be just 0, and the initial velocity in the x direction will be just, of course, 20 meters per second. And it is projected from height h meter above the horizontal ground. So this means when it hits the ground, the distance traveled will be just equal to h in the y direction, and the time it takes when it hits the ground is 5 seconds. A, you are asked to find h, and that's very straightforward. As we have said earlier, h will be just the distance y when it hits the ground. And B, you are asked to find the horizontal distance between the point of projection and the y when it hits the ground. So basically the horizontal distance in the x direction. So now let's look at the solution. So if you look at the solution, what is given is in x direction, initial speed is 20 meters per second, and since it is projected horizontally in the y direction, initial speed will be 0. Now of course when it hit the ground, the distance traveled will be just equals to the distance traveled in the y direction, so y will be just equals to h. And when it hits the ground, the time taken is 5 seconds. Right. So if you look at the schematic diagram, at time t is equal to 0, your particle is here, and it is projected with initial speed 20 meters per second horizontally. So there will be no initial velocity at the point of projection. But after the projection, the y direction motion will be constant acceleration. Both the velocity and acceleration is downwards. So it is speeding up or accelerating motion. So we have to take the acceleration as positive. Now in the x direction, it's just uniform velocity or constant speed. And now, if you look at the height h, which is just equals to the distance traveled in the y direction between the point of projection and when it hits the ground. So when it hits the ground, the time is 5 seconds. And you are also asked to find the horizontal distance between the point of projection and when it hits the ground. And that is, in fact, the x distance in the x direction. Right. Now if you look at the solution in the y direction, initial speed u is 0, and the acceleration is 9.8 meters per second square, and the time t is 5 seconds. And the distance in the y direction, of course, for constant acceleration motion, is just ut plus half at square. And you know u is 0, t is 5, a is 9.8, and the time is 5. So after computing that, you will get the distance in y, which is just the height h, 122.5 meter. And this is the answer to part A. Now if you look at part B, we have to find the horizontal distance. And of course horizontal distance is in the x direction. And in the x direction, u is just 20 meters per second. And since it is uniform velocity or constant speed, the distance traveled will be just u times t. So x equals u times t, u is 20, and the time is 5, and you will get the answer is 100 meter. So this is the solution for the distance in the one direction, right? So that is the solution to the problem, and I think that is very straightforward and also very similar to one of the problem that we have made. And so here we will skip the part about making sense of those are the numbers that you get, because it's very similar to one of our problems in the video. So those of you who haven't watched, please go and watch the video of the similar problem last time we did, right? So now let's just do problem number 2. Okay, now let's look at problem 2 of exercise 1A together, and let's read the problem first. So if you look at the problem, a particle is projected horizontally with a velocity of 18 meters per second. Find A, the horizontal and vertical components of the displacement of the particle from the point of projection after 2 seconds. B, the distance of the particle from the point of projection after 2 seconds. So if you look at this problem again, it is horizontally projected initially. So this means the initial speed u in the y direction will be just 0. And of course, initial speed in the x direction will be 18 meters per second. And we have to find horizontal and vertical components of the displacement at time t is equal to 2 seconds. So if you look at that problem, the initial velocities for both x and y direction are known. And then of course you are asked to find the x and y distance after 2 seconds. So if you look at the motion in the x direction, it's just constant speed. And if you look at the motion in the y direction, it's constant acceleration. And in the x direction, the distance is just u times t, and both u and t are known. So total distance in the x direction can be found. A vertical component of the displacement y will be just ut plus half at squared, because it is constant acceleration motion. And if you look at that, we know both u and t. For acceleration, because it's just acceleration of free fall, which is just 9.8 meters per second square. So we know all the parameters that we need, and we can find horizontal and vertical components I think straight away, right? And in part B, you are asked to find the distance of the particle from the point of projection after 2 seconds. So this is the straight line distance between the point of projection to the position when time t is equal to 2 seconds. And of course, if you look with the diagram later, I will show you, it's just the straight line distance between the starting point and one at time t is equal to 2 seconds. So this is the way we think about the problem, and now let's try to look at the solution. So again, this is very quite straightforward problem, and so this is the schematic of the diagram. At time t is equal to 0, it is just projected horizontally, right, with initial velocity in the horizontal direction is 18 meters per second, and vertical is 0. And of course, after projected, y direction is constant acceleration, so velocity vy is downwards, and acceleration g is also downwards, so it's constant acceleration motion. And at time t is equal to 2 seconds, let's say the particle reach here, right? And of course, at the position, the horizontal component of the displacement is just x, the vertical component of displacement is just y. So in part A, you are asked to find x and y. And then in part B, you are asked to find the distance between the point of projection, which is just the starting point here, and the position at time t is equal to 2 seconds. So you are asked to find this straight line distance d here. So if you look at d, the relationship between x, y, and d, x, y, and d forms a rectangle, a right angle triangle. So that is the reason d can be found when we know x and y using the Pythagoras theorem, right? So it's very straightforward problem. So let's look at the solution. So in the x direction, u is given 18 meters per second, and we are interested at time t is equal to 2 seconds. In one direction, u is 0 because again it is horizontally projected. In part A, we have to find x and y. In part B, we have to find the d, and the solution is very straightforward again. In the x direction, the motion is constant speed, so the horizontal component of the displacement x is just ut. So x is equal to u is 18, t is 2, so you will get 36 meter. In one direction, the motion is constant acceleration, so initial speed u is 0, acceleration is 9.8 meter per second square, and the vertical component of the displacement y will be just ut plus half at square. So u is 0, t is 2, acceleration due to gravity of free fall is 9.8. So after you work out, you will get 90.6 meter. So the solution to part A is this x and this y are the answer. Right. So now if you look at those two values, at time t is equal to 2 seconds, x is 36 and y is 90.6 meter. So x displacement is more than y displacement. But as the time progresses, you can see here y in fact vary with t square. So it varies with square function of time. But for the x, it's just linear function of time. So as the time progresses, the rate of increase in y will be, of course, definitely larger there. Right. So there's one important thing you should notice. And now for part B, we have to find d. So since x, y, and d form a right angle triangle, we can use Pythagoras theorem. So which is just d squared is equal to u squared plus y squared. So x from part A is 36, y is 90.6. And now of course if you want to get d, what you do is you will just take the square root on the other side, right? So square root of 36 square plus 90.6 square, and you will get 41 meter. And of course, actual answer is around somewhere 40.989 or something like that. But if you just round it to two significant figures, you will get just 41 meter, right? So this is the answer to part B, and yeah. So we have done two problems from exercise 1A, and of course in the future we will have more videos on our remaining problems in exercise 1A. So we want to invite you to subscribe to our channel and of course study with our videos. We hope that it will be useful for you. And with that, we will just say goodbye and see you in the next videos.